For the centuries, the rules of the 300 miles clubs were written in the stones. If you wanted to go that fast, you need 16 cylinders, 4 turbochargers, and mountains of mechanical gears. But the old rules are dead now. An electric vehicle from a company that started out to make phone batteries just laid down to staggering top speed of 308.4 miles per hour. That's nearly 500 km per hour at the Papenburg track in Germany, beating Bugatti. Yes, you heard it right, beating Bugatti. This is the Yangwang U9 Extreme. It doesn't just match the world's ultimate speed benchmark. It completely rewrites the chassis physics. Namaste dosto, I am Pushkar Kant with more than 10 years of experience in design and development, and trust me when I say what does this car does, it's pure engineering witchcraft. It can dance, it can jump, and literally it can drive on 3 wheels. Here is the raw, unadulterated engineering behind the China's software-defined hypercar revolution. If you're living in the Western market or maybe in Bangalore or Delhi, you must be thinking, what the hell is Yangwang? They are the ultra-luxury flagship division of BYD, a high-tech titan that began in 1995, manufacturing rechargeable phone batteries before building city-sized mega factories and hiring a small army of nearly 120,000 engineers. Think of them as a hardcore engineering laboratory for the brand. And their engineering philosophy starts with total paradox. Yangwang built 3 completely different flagship vehicles, a luxury sedan called U7 making 1300 horsepower, a massive apocalypse radio off-roader called U8, and the 2-door U9 supercar we are talking about today. Here is the kicker, all 3 of these incredibly distinct vehicles are built on exact same structural EV platform, the E4 architecture. For the fellow automotive engineers out there, you know how insane this is. That is the architectural equivalent of building a low-slung carbon fiber supercar on the rugged Mahindra Scorpio or any Tata pickup truck chassis. It sounds completely bonker until you look at the underlying mechanics. Traditionally, all-wheel drive systems are constrained by the central power source distributed through a mechanical differential, creating a latency and limiting how energy moves. The E4 platform completely deletes the central drivetrain. It relies on the 4 independent permanent magnet motors, 2 in the front, 2 in the back, giving each individual wheel its own dedicated instant brain. Because each corner is completely independent, the U9 moves vehicle stability control from reactive system to highly proactive torque vectoring marvel. Traditionally, ESC, electronic stability control, wait for a car to lose a grip, then clamp the brake caliper to slow you down, sacrificing your momentum. The E4 platform's quad motor torque vectoring system loops feedback at an ultra-high control frequency exceeding 100 times per second. Instead of subtracting energy via braking, low-level controller instantly recirculate and redistribute positive torque to push the car into the line faster than the human can blink. By shifting power dynamically across the corners, the system optimizes the tire slip angles by maximizing the contact patch. On the track, this independent management allows a heavy vehicle to physically pivot through the apex, generating a brutal 1.7 g of a maximum lateral acceleration without overwhelming a single tire. But if the standard U9 on the market puts out roughly 1300 horsepower and tops out at an electronically limited 186 miles per hour, how did the extreme variant turn out to be the fastest car in the world and achieving 308 miles per hour? Well, it comes down to electrical architecture and absolute thermal management. The base car runs on the standard 800 volt system, but to build the fastest production car on the earth, the engineers stepped into the uncharted territory, a world first mass production of 1200 volt ultra high voltage platform. What does that actually mean for performance? In basic physics, power is nothing but voltage multiplied by current. If you want to dump a massive energy into the electrical motor using lower voltage, you have to ramp up the current, meaning more physical amps pushing through the copper wires. But high current generates devastating heat loss. The massive overvolting of 1200 volts, the U9 Extreme delivers a relentless torrent of energy with lower current, slashing resistance heat loss by a staggering 67%. This allows to upgrade the motor to spin at an 30,000 rpm. Instead of making 300 horsepower per wheel, each motor is overclocked to output 744 horsepower, combining for a mind-numbing 2,976 horsepower. Feeding that electrical demand requires serious chemical stability. Traditional hyper EVs relies on the volatile nickel manganese cobalt chemistry. BYD utilized their proprietary structural lithium manganese iron phosphate. By infusing manganese into the cathode, they elevate the voltage platform from 3.2 to 3.8 volts, pushing cell energy density up to 250 watt-hours per kilogram. Now let's discuss on the most famous ability of this car, the ability of fly, jump and dance. Yes, it can dance. It's a dancing car. While PK dancing car have very different reason for shaking, the U9 does it through pure unadulterated vertical force control. This is the Disus-X intelligent body control system. It uses high pressure hydraulic actuator at all four corners capable of an adjustment speed exceeding 500 mm per second, outputting 9 kW of a bi-directional pressure per wheel. To jump, car completely compress its suspension stance, then instantaneously fire all 9 kW of a hydraulic pressure downward into the pavement, creating enough rapid vertical force to clean launch of a 5,500 pound vertical straight off the ground. Now it looks like a pure marketing gimmick, but its practical application is pure active safety engineering. Honestly, when I look at this active suspension, I don't think of the track days of Germany. I think about our everyday Indian roads. Imagine navigating the lunar craters of the Mumbai monsoon road or the surprise potholes of the Bangalore outer ring road. This car wouldn't just glide over them. It would practically play hopscotch over the potholes. If a driver suffers a catastrophic tire blowout at the 120 miles per hour, traditional mechanical car risk a violent rollover. But the U9 uses the God-size sensors arrays to scan the road up to 150 meters ahead of the lidars and cameras. If a blowout occurs, the E4 system corrects the vehicle's trajectory via the remaining wheels in milliseconds, while the Disus-X active suspension instantly shifts the vehicle's physics masses away from the damaged corner. It lifts the wheel hub completely off the ground and stabilizes the body roll, allowing the car to drive out the danger smoothly on just 3 wheels. Of course, the massive technological shift like this comes with few technical asterisks. To claim the official production car top speed record, a car must complete 2 back-to-back high-speed runs in opposite direction within 1 hour to completely neutralize any tailwind advantages. The Yangwang team didn't do that in Papenburg. Driver Mark Bezing took 2 warm-up laps and hit 308.4 miles per hour on his third pass before packing it for the day. Because it was a single direction shakedown pass, the official certified 2-way record held by the traditional combustion cars remains technically safe for now. But the era of defining ultimate hypercars solely by gears, cylinders and displacement is over. The software-defined speed era is officially here. So what do you think about this supercar made by the Chinese car maker Yangwang? Would you like to purchase if it comes in India? The dancing car, the flying car? Comment below. So thank you everyone. लगता है RCB जीत गई है. Yeah. That's it from my side. Hope you like this content. If you like this content, do like, share and subscribe. Thank you.
Step on the pavement, feel the heat in your soul. Prepared or not, man, you gotta take control.